Hi there, today we will learn a new topic. It's about applications of differentiation. And today we will learn more on finding the gradient of the tangent and normal at a point on a curve, and also finding the equations of the tangent and normal to the curve. Now, look at this point A. At point A of this curve, we see that there is a line at that point A, and that line is being called as the tangent. And when we find the dy of the x, which refers to the gradient at point A, it refers to the gradient of tangent at point A. What about normal? Normal is just a line which is perpendicular to the tangent line. So what would be the gradient of the normal line? The gradient of that normal line would just be, it would not be the same as the gradient of tangent line because it is perpendicular, so the gradient of normal line is -1 over m if the gradient of tangent line is, let's say, we equate it to m. So the important thing for you to remember for tangent is the gradient of tangent line is dy over the x or is equal to m. And the gradient of normal line is equal to -1 over that m. So this means if you want to find the gradient of normal line, we have to first differentiate, finding the value of dy over the x, and then you put -1 over that value. Now what about the equations of the tangent and normal lines? The equation of the tangent line is y minus y1 equal to m times x minus 1. Equation of the normal is also the same. But now, as you can see, the only difference is just at the gradient part, because we would have different gradients. So the gradient of the tangent is just dy over the x, which is equal to that value of m. And then the gradient of the normal would just be -1 over that m. Okay, can you memorize these formulas? What is this y1 and what is x1? It would be the coordinates of the point A. Let's look at example 1, finding the equations of the tangent to the curve at point 1,5. So the keyword here is the word tangent. We want to find the equations of the tangents to the curve. Whenever you come across to the word tangent, what you have to remember is the formula to find the gradient, which is dy over the x. And then, since you want to find the equation of the tangent, what you have to remember is the formula to find that equation. And what's the formula to find the equation? It's y minus y1 equal to the gradient m times with x minus x1. Once you remembered all of this, you can proceed. This is the equation, y equal to x squared plus 2x plus 2. This is an explicit function, so just differentiate it as usual. Differentiate x with respect to x. X squared, you get 2x. Differentiate 2x, you get 2. Differentiate a constant, you get 0. Now this is your gradient. But what is the value of the gradient at the point 1,5? So this is our value of x, and 5 is our value of y. Now just substitute your value of x, 1, into dy over the x. Solve it and the answer is 4. Now let's say this is our curve and the point 1,5 is somewhere over here. So the gradient of the tangent is a line straight at this point, and finding the equation of the tangent means finding the equation of this line. How to find the equation of that line? Remember, it's just this formula. So write down your formula, y minus y1 equal to m times x minus x1. And then just replace your value of coordinate 1,5 into y1 and also x1. So replace that with 1 and 5. Once you have replaced all of the y1 and x1 with the coordinates 1, 5, next, what should you replace your m with? What is this m? Remember, this m is just referring to the value of the gradient. So dy over dx is that m. And what is m? So m is 4. Just substitute your value of m with 4. Simplify this, you get 4x plus 1 equal to y. Stop until there because this is your final answer of the equation of tangent. Now, example 2 wants you to find the equations of the normal to the curve at the point 2, 4. What is the keyword in this question? The keyword is normal to the curve, and we want to find the equation of the normal to the curve. Now, when you see the word normal, how to find the gradient of normal line? The gradient of the normal line is negative 1 over m. And how to find the value of that m? Remember that m is just equal to dy over dx. So this means we have to differentiate the equation, and then after that, putting a negative 1 over that value of m. Next, to find the equations of that normal line, the same formula applies, which is y minus y1 equal to m times with x minus x1. But this is not m because m is the formula of gradient, so this should be negative 1 over m, because now the gradient of a normal curve is negative 1 over m. So for tangents, for equation of tangent, it's just m because the gradient is just m. But for gradients of normal, for equation of normal, the gradient is negative 1 over m. So that's why we replace that value with negative 1 over m. So what is our first step? The first step is to find the value of m so that we can replace it and write negative 1 over m. Now, just differentiate. What you get is 2x. But now we want to find the gradient exactly at the point 2, 4. So what is the value of x at that point? The value of x is 2 and the value of y is 4. So replace your value x with 2. And the gradient exactly at point 2, 4 is 4. Is this the gradient of normal to the curve? No, this is just the gradient of tangent to that curve. If it's hard for you to visualize, let me show you. If this is our curve y equal to x squared, and the point 2, 4 is somewhere here, the gradient m equal to 4 simply refers to the gradient of tangents at that point. So, what is the normal to that curve? Normal to that curve is just a line perpendicular to the tangent line. So, what is the gradient of this normal line? The formula is negative 1 over m. So, since our tangent line gradient is 4 and m is 4, so normal line gradient would be negative 1 over 4. So, to find the gradient of normal line is negative 1 over 4. What about the equations of the normal line? Equation of a line will always be y minus y1 equal to the gradient of that line multiplied with x minus x1. And what is the gradient of a normal line? The gradient of normal line is negative 1 over m. And we have found this value negative 1 over m here. So just replace your value negative 1 over m with negative 1 over 4. Now, what about the value of y1 and x1? What should we replace it with? It is the coordinates at that line, which is 2, 4. So our x is 2 and y is 4. Replace your value with 2 and 4. Expand and simplify. And that's your final answer. Now, I would like you to try example 3. It's just finding equations of the tangents and normal to the curve at the point 2, negative 4. Try it out. In example 4, we would like to find the coordinates of the points on the curve where the gradients of the tangents is 4. Next, find the equations of the tangents at its points. This question wants you to find the coordinates of the points on the curve, where we know that the gradients of the tangents at that coordinate is 4. So the key word here is gradients of tangents. Whenever you see that, remember that refers to dy over dx, and the value is already given, which is 4. So dy over dx is equal to 4. So to find the coordinates, we have to first differentiate this equation and then equate that derivative with 4 to find the value of x and y coordinates. Start by differentiating. 2x cubed, when you differentiate, you get 6x squared minus 6x minus 8. And this is equal to 4. This is a quadratic equation, but you have to bring 4 to the left side. And now the right side is equal to 0. After it's equal to 0, you can press your calculator to find your factors. From your calculator, you will get 2 answers. So write it in terms of factors, x minus 2 times with x plus 1. But if you try to expand this, you get x squared minus x minus 2. And it's not equal to the original equation before we press our calculator. So how to make it equal? You have to check. There must be a number that we have to multiply it with. So this means we are lacking the number 6. If we multiply everything with 6, then this would equal. So the same thing to do here. We just have to write 6 in front of the brackets. Always check that your factorization is equal to the equation before it. Now you have two values of x equal to 2 and x equal to negative 1. We want to find a coordinate. A coordinate is always in the form of x, y. But this is just the value of x. How to find the value of y? To find the value of y, just replace your x into the equation. Replace your value of x with 2 and also with negative 1 into the equation to find the value of y. Once you have found the two values of y, now we know what is the coordinates. So the coordinate is 2, negative 5 is the first coordinate. The second coordinate is negative 1, 10. So the coordinates of the points on the curve which have the gradient equal to 4 are 2, negative 5 and negative 1, 10. Next is to find the equation of tangent at these points. The question just wants you to find the equation of the tangents at these points. But do we know what is the gradient of tangent at that points? Well, it's already given from the question. Dy over dx is equal to 4, and this is the gradient of this tangent. So we don't have to find what is m. Straight away proceed with the formula of equation of tangent. Start with the first points. Equation of tangents at 2, negative 5 would be, the formula is y minus y1 equal to the gradient m times with x minus x1. And what is x and what is y here? The x is 2 and the y is negative 5. What about the value of m? It's already given in the question, which is 4. Now please be careful. Your value of y is negative 5. In front of this y, there is already a negative. So make sure you put a bracket here, which refers to the y is negative 5. Then expand and simplify. But we are not done yet, because the question wants you to find the equations of tangent at its points. And we have 2 points with gradient 4. So we have to find another equation of tangent at the point negative 1, 10. The same formula applies. Y minus y1 equal to m times x minus x1. It's just that now our value of y and x coordinates are different. Y would be 10 and x would be negative 1. What about our gradient? The value of gradient will not change because it's just 4, since negative 1, 10 also has the same gradient. Now be careful with your value of x because it's negative. So write a bracket before you write negative 1. And this would be your equation of tangents of the second point. And you are done answering this question.